Looking at this photograph of Saturn, it is immediately recognizable. The massive, brilliant ring structure makes it the most distinct planet in our solar system. Visual majesty can obscure physical scale. If you pull a dimensional bracket across the entire system, the rings measure 280,000 kilometers wide. To put that into perspective, lining up 20 Earths side by side would barely span the distance from edge to edge. From a distance, the rings mimic a solid, permanent track, though this smooth surface hides a much more complex reality. If you take a spacecraft and fly directly into that incredibly bright cosmic plane, the solid optical illusion completely breaks down right before your eyes. You won't hit a continuous sheet. Instead, you'll find billions of chunks of highly reflective water, ice, and rock tumbling through the vacuum of space. This close-up photograph reveals something else hiding within the debris: massive stretches of completely empty space, known as ring gaps. Right in the middle of that void sits a tiny moon, actively orbiting and sweeping the path clear like a cosmic snowplow. This brilliantly disguised highway of fragmented debris is a massive graveyard of ice, demanding an explanation for its origins. The prevailing explanation is that these rings are the shattered remains of an ancient icy moon that wandered dangerously close to the gas giant. Every planet has an invisible physical boundary around it called the Roche Limit. If a moon crosses that line, the planet's gravitational pull becomes totally destructive. This diagram shows how that works. As a moon approaches, Saturn's immense gravity acts unevenly. It pulls significantly harder on the leading edge of the moon than it does on the far side. Eventually, that gravitational shear creates internal stress that overcomes the moon's own gravity. The satellite fractures and literally gets ripped into pieces. Over millions of years, those jagged fragments continue to orbit, colliding and grinding each other down, eventually spreading out to form a thin, flat disk. These rings represent the wreckage of a destroyed world, beautifully distributed long after Saturn first formed. If orbital physics dictate that shattered moons create rings, it seems odd that Saturn would be the only planet to display such a highly visible set. But look at Jupiter in this image. It possesses its own ring system, though the debris is so thin it's nearly invisible. Uranus, shown here, also has rings, but its debris is similarly dark and faint. And this close-up of Neptune reminds us that the farthest gas giant also harbors faint rings. All the other giant planets have ancient rings polluted by billions of years of dark space dust. Saturn's rings are uniquely brilliant simply because the destruction of its icy moon happened much more recently. The ice hasn't had time to get dirty. But that bright ice is already disappearing. Saturn's rings are actively losing a long battle against the planet's gravity. Through a process known as ring rain, the icy particles are gradually losing their orbital momentum. As the ice slows, it gets dragged along Saturn's magnetic field lines, creating a torrential downpour of glowing particles vaporizing into the atmosphere. Looking at this chronological timeline, you can see the terminal rate of decay. The material is draining so fast that the entire ring system will completely vanish in roughly 100 to 300 million years. The rings are a dying, temporary monument in our solar system. Humanity simply happens to exist at the exact right moment in cosmic history to look up and see them.